And if we are summarizing what code RealTime is, first of all, so it's a tool for creating stateful event-driven real-time applications in C++. And you could easily see that that description is actually exactly the same as model RealTime. So what are the differences if we compare with model RealTime? Yeah, in this table, I've added some of the key differences worth noticing. So first, there is a difference in what IDE it runs on. So model RealTime is an Eclipse-based application running on the Eclipse IDE. Code RealTime, on the other hand, runs in Visual Studio Code or Eclipse Thea. There is also a difference in the language that you use when you're creating your applications. So with model RealTime, you use UML, and in particular, the UML RealTime and C++. While in code RealTime, you use a language called Art and C++. And there is also a difference here that UML is a quite big language, and there is some overlap with C++. For example, if you're going to create a class, you can do that either in C++ or you can do it in UML. In Art, there is no such overlap. We have removed such things from the language, and it means that Art is a significantly smaller language than UML RealTime and only contains those concepts that don't exist in C++. There is also difference if we look at how the files that you create are stored. So in model RealTime, they are stored as XML files. In code RealTime, it's the Art files that you edit that are stored. That's what you put into your SCM system like Git. Code generation is also different in the sense that in model RealTime, the code generation happens on demand when you are building a TC, while in code RealTime it happens automatically and updates as soon as you edit something that affects the generated code. The same goes for the validation. I mean, the checks that we run in model RealTime, there are some checks when you build with the model compiler. However, they are a bit limited. In code RealTime, the checks are run also when you edit the Art files or the TC files, and they are more extensive checks in code RealTime. Diagrams is also a difference. In model RealTime, diagrams have manual layouts. You move things around and place them where you like to. While in code RealTime, we are currently only having automatic layout. But also note that many things remain the same. So the same language concepts exist. So capsules, protocols, state machines, ports, events, etc. Those things that you know from model RealTime, they also exist in the Art language and in code RealTime. Also, transformation configurations are the same with very few differences. So the TCJS files that is used in model RealTime for building applications, the same TCJS files can also be used in code RealTime. The runtime library, the TargetRTS, is also the same, and that's important because that ensures that the API that you use in C++ code snippets is the same. So there are no differences there. And if you look at the generated code, you will maybe at the first glance think that it's identical. It's actually not identical, but almost identical. So we made some improvements in the generated code in code RealTime, but to the large extent, it's very similar. So any questions on this overview of code RealTime, what it is and how it compares with model RealTime?
Sorry, go ahead.
Is there a plan to allow manual layout? For example, a lot of our models are relatively complex, and the layout really helps understanding.
Yes, yeah, that is something we are working on. So automatic layout has its benefits, in particular when it comes to maintenance of diagrams, that you don't need to spend time maintaining them. But as you say, sometimes the automatic layout is not as clear as a manual layout would be. So we are working on supporting the ability to first move symbols as a first step, and later also resizing them and control how lines are routed in the diagrams. Was there another question also?
Yeah, the manual layout would also something that we would be very interested in. One other thing, you mentioned a few minor improvements in the code generation. Will those also be backported to model RealTime?
Some may. It's a little bit depending on case by case. And one of the improvement, for example, we did because of the way Code Real-Time works with that it's more code-centric. So for example, in Model Real-Time, when you have a capsule, the class that is generated has the suffix _actor. That is not a big deal in Model Real-Time because you reference that name quite infrequently, typically only when you incarnate an optional part or something like that. While in Code Real-Time, since we then use C++ to a larger extent, you use that much more often. For example, if you want to add a member function to your capsule. So we have decided in Code Real-Time to use the capsule name without suffix. So that is a difference. But we think that is such a small difference that it's manageable, but something that we probably will not backport to Model Real-Time.
Yeah, okay, that makes sense.
Yeah, and there are other things that we have done that we probably could backport, like generating some comments to make the code a bit more clear and some other things. But I think it's a case-by-case decision what makes sense to backport and what makes not sense.
Okay, clear. Thank you.
Any other questions?
And can you inherit from capsules?
Yes, that's the same thing. That works the same as in Model Real-Time.
Okay.
So language-wise, it's very similar.
And is there the ability or a plan to be able to? So we have a large framework that we use to build our instrumentation software that is based in Model Real-Time, and would like to say we migrated to Code Real-Time, would like to be able to somehow easily port it.
Yes, so there are two different ambitions we're working on. One was demonstrated on Monday in the Model Real-Time demo, where we recently have added support for taking art files you have created in Code Real-Time and use them in Model Real-Time. So that scenario is that you prefer to continue to work for the most part in Model Real-Time, but you have some libraries or something that you want to migrate to Code Real-Time, and then you could use them in your Model Real-Time applications. So basically it allows you not having to migrate all at once, but more like a gradual approach where you do it library per library. But we're also recently started working on something we call Art Exporter. So that's a utility that you can install on Model Real-Time. It's in a still very early phase, but the idea is that that utility should help you convert the whole UML model or parts of it to art files. So that can be something that you can benefit from.
Okay, thank you.
In the hyperlink you see in the upper right corner, that goes to the web page of Code Real-Time. And as users of Model Real-Time, you already have access to Code Real-Time. So there are two versions of Code Real-Time. One, a community edition, that is what you get if you install it from VS Code, then or Eclipse, then it will be taken from the public marketplace. So then you get this community edition that has some restrictions, for example, no source code for TargetRTS and a few others. But if you have the entitlement to Model Real-Time, then you should get Code Real-Time from the same place where you get Model Real-Time, because then you have the full version there. And then you get this in VSIX file, which you then install into VS Code. So moving on to give the overview of what we will demo today. So in 2.0, we launched the first version of a debugger, which we call Art Debugger. This is very similar to the Model Debugger in Model Real-Time. And in this first version, it has the ability to launch the application to debug or to attach to an application that you have already started elsewhere, either locally on your machine or maybe on a remote target machine. And it will then connect over TCP to that application. We support pausing and resuming execution. You can stop and disconnect the debug session, and you can also restart to start from the beginning. There is a new view called Art Debug view, which shows the application runtime structure in the form of a capsule instance tree with the ports. So that is very similar to what you have in Model Real-Time. And on those ports, you can send events, incoming events on ports. And when you do that, you will be prompted to provide data if the event that you send has any data. And also if the port is replicated and has multiplicity, you will be prompted if you want to send it on a particular port index or if you want to broadcast to all ports. We have also improved the code generator. That's an ongoing thing we have worked on for quite a while, and we still have a few gaps compared to the model real-time code generator, and trigger operations with parameters was one such gap that we now have fixed. So now that is working, and it's also handled correctly by if you use context in an art file to create such a transition, or if you do it in diagrams. Another gap we had was that we didn't support all scenarios related to port multiplicity, so that we have also improved, and you will see some examples of that in the demo. Documentation is also something we continuously improve, and in this release we have written new chapters about TargetRTS, about logging, how the defer queue works, and how unhandled messages are handled. And that we also added a chapter about samples, because I think we already have around 20 samples, so it starts to become quite many, and it was useful to have this summary and introduction of what each sample shows, so you can pick the one that you're most interested in. And there are a few new samples in this release. I mentioned here the distributed ping pong, token ring, and TCP range counter. They were all enhanced or created in this release, and these three samples all make use of a library called TCPServer library. So that library is direct port of the library with the same name from model real-time. So it basically allows you to do two things. One is to expose a TCP-based API where you can send JSON requests and have those requests translate into injection of events on ports. On a capsule part. So that's useful and used in the TCP range counter example. The other capability is that you can use it as a simple means to build a distributed application where the output from one application is routed to another application. And that's used in the distributed ping pong, where two applications are connected and sending ping and pong back and forth. And the slightly more elaborated example, token ring, that I will show in the demo, where you can connect many applications in a ring and send messages between them. We have also created a web sample for showing how you can use a web page or web application to communicate with an application. And this uses the RTTest probe library that we have used also for model real-time for some time, to make this easier in a JavaScript-based context. We also continuously implement new validation rules, and in this release we have added a check related to TCs, so that now if you have a TC that depends on itself through a prerequisite, directly or indirectly, you will get a warning. That's useful to avoid strange build problems if you happen to have this. So also like to give you a brief intro of what are we currently working on, and not all of this may go into the next release, which is 2.01, planned for early November, but these are all areas that we are working on, and some of that will be available in 2.01. So we'll continue to work on the code generator to fill gaps, and one gap is the support for trigger guards in capsule and class state machines. They are currently ignored, but we have almost completed that implementation. We also want to support internal transitions in class state machines that are not supported right now. And we have improved and a bit redesigned the way how we translate choices to make them better. So that will also most likely go into the next release. Art Debugger is right now only in its first phase. So now we're working on showing the active state of a capsule instance, supporting breakpoints, at least state and transition breakpoints are quite useful. And also tracing, of course, so that you can trace what communication is taking place in your application. We mentioned already previously here the manual diagram layout. We have a prototype working on this, but we need to test it more to make sure that it's this layout information that we save is always handled correctly and never lost. And then the art exporter, that is not really part of Code RealTime, but it's strongly related, of course, to Code RealTime because it's a utility that we will release separately. Most likely it will be placed on the utilities page on the Model RealTime Info Center. And then you can install that on top of Model RealTime to get an export wizard that can allow you to export parts of your Model RealTime model to art files to be used in Code RealTime. And we have started with the data types as the first step. So if you have data types like classes, enums, type aliases and other things in your Model RealTime application, it's useful to be able to export them so that you can use them from your Code RealTime applications.